Okay, this is for section 2.3, the product and quotient rule. Today you will be able to find the derivative of a product of expressions using the product rule, and you will be able to find the derivative of a rational expression, or simply just a problem where you have division using the quotient rule. So in order for us to, this is the product rule right here. So we have the derivative of an expression times another expression, or a function times a different function, is we take the first one times the derivative of the second one plus the second one times the derivative of the first. So first times derivative of the second plus the second times the derivative of the first. Okay, and I'll show you an example of how to use this. Okay, so for example, if I were asked to find the derivative of the function h of x equals 3x minus 2x squared times the quantity 5 plus 4x, well, we say that here's my first one, here's f of x, and the second one, the second factor that I'm multiplying, here's g of x. And so in order for me to find this derivative, I need to follow the rule, the product rule. And we're going to take the first expression times the derivative of the second plus the second times the derivative of the first. That's the product rule. So the derivative is equal to the first one, which is 3x squared minus 2x, or 3x minus 2x squared. Didn't do anything to it, leave it alone, times the derivative of the second. So now I'm going to take the derivative of the second expression. The derivative of 5 is 0. The derivative of 4x to the first power, right? So it's 1 times 4, and then there's no more x, so it's just 4. And then plus the second, which is just 5 plus 4x, times the derivative of the first. And the first, the derivative of 3x is just 3 minus the derivative of 2x squared is 2 times 2, which is minus 4, and then drop the power down 1 using my power rule, which is just minus 4x. Okay, let's clean this up. We can simplify. I'm going to distribute 4 times 3x, which is 12x, minus 2x squared times 4, which is minus 8x squared, and then plus, I'm going to FOIL this, 5 times 3 is 15, I don't need a parentheses there, and then 5 times negative 4 is negative 20x, and then 4 times 3 is plus 12x, and then 4x times negative 4x is negative 16x squared. Okay, we're going to combine like terms. Remember, this is for the derivative. Combine like terms, I got negative 8x squared minus 16x squared, and I get negative 24x squared. And then 12x minus 20x plus 12x, that's going to be negative 4x. Then plus 15. And that is the derivative. For our second example, I have find the derivative of y equals 3x squared sine x. I do have a product here, and the product is between these two functions right here. I have 3x squared, that's considered as one function, that's f of x, and I have sine x, and that's considered my second function. Okay, so it's the first times the derivative of the second plus the second times the derivative of the first. So following that, I get y prime equals the first. 3x squared times the derivative of the second. Derivative of sine x is cosine x. And then plus the second, which is sine x, times the derivative of the first, which is Derivative of 3x squared. 2 times 3 is 6x to the, drop down the power by 1, and it's just 1, so that's what I get. And I'm going to clean it up a little bit so that it looks better. So 3x squared cosine x, and I'm going to bring this 6x over here in the front, 6x times sine x. That looks a little bit better. There's nothing else I can combine, so that's my final answer. For the third example, we have find the derivative of y equals 2x cosine x minus 2 sine x. Okay, this one is a little bit different because I do have a product right here. This is f of x, and then this is g of x right here, that cosine, that's g of x. However, this last term over here, 2 sine x, we're going to treat 2 like just a coefficient. Okay, and the sine x is going to be just like a variable on its own with a coefficient. Okay, so when I take the derivative, this time I'm going to write dy dx. You know, it's just a different notation. It all means the same. So I'm only going to use the product rule on this part right here. So I'm going to do the first times the derivative of the second, which is negative sine x, plus the second cosine x, times the derivative of the first. The derivative of 2x is just 2. And then minus 2, and then I take just the derivative of sine, which is going to be cosine x. Okay, and so now I'm going to clean it up a little bit. Negative 2x sine x plus 2 cosine x minus 2 cosine x. And then I notice that these two are the same, and then I can cancel those out, which leaves me just negative 2x sine x. So this is my final answer. Okay, so I'm going to show you the quotient rule now, and then I'm going to teach you how to yodel. So remember yodeling, like yodel-a-hee-hoo, all that stuff, blah, blah, blah. I'm not going to sing. But I teach it in a way that you could, or be easier for you to remember, which is by yodeling. And then I know that Mrs. Bathgate teaches you pooping, the pooping method, but I'm not going to show you that right now. I'll show it to you guys later to see if maybe it's a different way for you to help you guys remember the quotient rule. But for the quotient rule, and the way that I do it, I call the numerator, this is called high, of course, because it's on top, and then the denominator is called low. And so the way that I remember it is yodeling. So, oops, I started the wrong way. So I start with low, and then D high, minus high, D low, all over low squared. And I'll show you what that means with the real math way, but this is how I remember it. It's low D high minus high D low all over low squared. Okay, so it kind of sounds like you're yodeling. Low D high minus high D low all over low squared. Okay, that's enough. All right. So, but this is what it really is. You take the bottom function, and then you multiply it with the derivative of the numerator. So that's f prime of x, and then subtract the numerator f of x times the derivative of the bottom one. See, d low. The d stands for derivative. Derivative. Okay, so times the derivative of the low, or the denominator, all over the denominator squared. And that is the formula. So let me apply the rule, the quotient rule, to find the derivative of this rational expression. I have 5x minus 2 over x squared plus 1. Oh, can you just imagine doing this with the limit process? That would be very messy. But anyway, now we have our quotient rule. Okay, and then, so remember I told you it is low d high minus high d low all over low squared. Okay, so I take, this is high up here, this is the numerator, so it's high, this is the denominator, so it's low. So to find the derivative, y prime, we do low, so the whole bottom, the whole denominator, times the derivative, remember d stands for derivative, of the high, of the numerator, so derivative of 5x minus 2 is just 5. And then minus high again, so high is 5x minus 2. And then d low, so the derivative of the bottom, so the derivative of the denominator is, we take that out in front, so just be 2x. And then derivative of 1 is 0, so it's just 2x. All over low squared, so I'm going to have all over the whole denominator squared. Okay? Looks a little bit messy, but nothing that we can't clean up, so let's simplify a little bit. So that's 5x squared plus 5 minus, and then 2x. 2x times 5x is 10x, and then 2x times the negative 2 is negative 4x. Oops, that one's squared. All over, this is, I'm just going to leave that one alone, x squared plus 1, quantity squared. And I'm going to distribute that negative, so that becomes a plus, that's a minus, and that's a plus after I distribute it over there. So I have 5x squared minus 10x squared, that gives me a negative 5x squared. 4x doesn't combine with anything, so plus 4x. And then plus 5 all over low squared, which is just going to, I'm going to just keep it as x squared plus 1 quantity squared. And you can do that too. We don't want to get too crazy. We just clean it up as much as we can. This is overkill if I try to FOIL the bottom, so I'm just going to keep it like that. Okay, so in this example, it's telling me to find the equation of the tangent line to the function f of x equals 3 minus 1 over x all over x plus 5 at the point negative 1, 1. Okay, so again, anytime it's asking you to find the tangent line, that means we are looking for the slope of that tangent line, which means that you are going to find the derivative. And in this case, I have a super ugly function, so I want to rewrite it before I take the derivative. Okay, so let's rewrite that sucker. So we have f of x equals 3 minus 1 over x, and I just know how much you guys love these kinds of functions where I have complex fractions. Alright, so I'm going to put that over 1 so that I can get common denominators in my numerator. So I'm going to multiply this by x, multiply this by x, and I get 3x minus 1 over x all over x plus 5. So this denominator didn't change. Okay, now I'm going to multiply by the reciprocal, so put that over 1, then multiply by the reciprocal, so I don't have that anymore, so I have 1 over x plus 5, which means that now I have 3x minus 1 times 1, which is just 3x minus 1, over x times x plus 5 gives me x squared plus 5x. Now this makes it a little bit easier to find the derivative. So in order for me to find the derivative, I'm going to use the quotient rule. I do have a fraction here. I have a numerator and I have a denominator. I have a high, I have a low. So let's do it. So remember, low d high minus high d low. Low is x squared plus 5x. D high, that means take the derivative of high. So the derivative of 3x minus 1 is just 3. Minus high, so 3x minus 1 d low, take the derivative of the bottom. So that's going to be 2x plus 5 all over low squared, which is x squared plus 5x. Oh, quantity squared. Okay, so I'm going to clean it up a little bit. Let's distribute 3 times x squared. That's 3x squared. 3 times 5x, that's plus 15x. Then I'm going to FOIL this part. Don't forget the negative needs to be distributed. So 3x times 2x is 6x squared. 3x times 5 is 15x. Negative 1 times 2 is minus 2x. Negative 1 times 5 is minus 5. And that's still all over x squared plus 5x quantity squared. And I'm not going to FOIL that. That's way too much work. Okay, so I'm going to distribute this negative, so that becomes a plus, minus, minus, plus, plus. Okay, combine like terms on top, so I have a 3x squared, and I have a negative 6x squared, which is going to give me a negative 3x squared. I have 15x minus 15x plus 2x, so plus 2x. And then I have just a plus 5 all over x squared plus 5 times 5x quantity squared. Okay, so that's again, this is my derivative, which is the slope. But since I still have variables in it, it just acts like a formula for your slope. So I'm looking for the derivative at that point, negative 1, 1. So now I get to plug in 1. So let's find f prime of negative 1. I'm sorry. What's my point again? Negative 1, 1. So plug in negative 1. So I get negative 3 times negative 1 squared plus 2 times negative 1 plus 5 over negative 1 squared plus 5 times negative 1 quantity squared. And that's going to be 1 times negative 3 is negative 3 minus 2 plus 5 over, that's 1 minus 5 quantity squared. So that's negative 3 minus 2 plus 5 is 0 over something. I don't even care about finding that out, which is just going to be 0. So my slope is 0. And then it's asking me to find the equation of the line. So I don't just stop at the slope. I actually have to find my equation. So if my slope is 0, I'm going to use y minus y1 equals m times x minus x1, your point slope formula. And then my point is negative 1, 1. So y minus 1 equals 0 times x minus, or plus 1 now, because it's a minus and negative 1. And all this just equals 0. So y minus 1 equals 0, y equals 1. Okay, and so what does that mean again when I have a derivative of 0? When I have a derivative of 0, that means I either had a minimum point or I had a maximum point. And so I have a horizontal tangent line at y equals 1 touching at that minimum point or that maximum point. Don't forget that. That's going to come in handy in a couple of chapters when we actually start sketching functions based on the derivative. So let's talk about more trig function derivatives. You already should know that the derivative of sine x is equal to cosine x, and you know that the derivative of cosine x is equal to negative sine x. Okay, and then now I'm going to show you that the derivative of tangent x is equal to secant squared x, and the derivative of, the derivative of of cotangent x is equal to negative cosecant x, cosecant squared x, just kidding. All right, and then I have the derivative of secant x, which is equal to secant x tangent x, and then the derivative of cosecant x is equal to the negative cosecant x times cotangent x. Okay, so you need to know these. You need to memorize these derivatives. Okay, and then also notice, I don't know if you've noticed, but all of the cos, what's happening with all of the cos? What did you say? I think you said it. They're all negative. Good job. So let's find the derivative. Here's an example of using our trig functions. Y equals 1 minus cosine x all over sine x. And remember, in pre-calc you should have learned that when we were proving those identities, those trig identities, I said one of your strategies is to separate the numerator. So if I'm either adding or subtracting my numerator, I can rewrite it as two separate fractions using my denominator, and that's what I want to do, because I don't want to use the quotient rule. That's too much work. So I'm going to rewrite this as 1 over sine x minus cosine x over sine x. Okay, this is basic trig identities. Okay, and so I know that 1 over sine x, well, that's just equal to cosecant x. And then minus, let me see, cosine over sine, that is equal to cotangent x. Okay, and now that I know my new derivatives, I can just simply find the derivative of these. So the derivative of cosecant x is negative cosecant x cotangent x, and then minus, and then the derivative of cotangent is negative cosecant squared x. Okay, so clean it up a little bit. We have negative cosecant x cotangent x, and now it's plus, negative and negative make a plus, cosecant squared x. And I'm done. Oops, y prime. And that concludes tonight's video. Hope you enjoyed. I will see you tomorrow.